In this tutorial, we are going to show you how to use Seed Studio's Grove Base BoosterPack with Energia to utilize a variety of standalone modules and sensors for fast prototyping. We will also show you specifically how various sensors can be read through either a serial port or a digital LCD display. Typical sensors and standalone modules that can interact with the Grove Base BoosterPack include temperature sensors, humidity sensors, accelerometers, gyroscopes, LEDs, gas sensors, and many more. For this example, we'll need an MSP430 F5529 launchpad, the Grove Base BoosterPack, and several sensors. The sensors that this code example interacts with include Seed Studio's water sensor, moisture sensor, rot pot sensor, MQ3 gas sensor which detects alcohol vapor, PIR motion sensor, LCD display, DHT11 temperature and humidity sensor, a buzzer, and finally an LED. This booster pack will work with many of our 20-pin or 40-pin launch pads supported by Energia. Start off by connecting your booster pack to the top of your launch pad while ensuring proper orientation. Now plug your launch pad to your computer over USB. You'll notice that on the Grove Base Booster Pack you have 13 independent slots to plug in modules. You'll probably also notice two switches located towards the bottom of the board, in addition to a bright red LED which indicates power. It turns out that the Grove Base Booster Pack can supply either a 3.3 volt or 5 volt supply to its connected sensor modules. Most of Seed Studio's modules will work off of 3.3 volts. However, a few need 5 volts to operate, such as the LCD display used in our code example. Switch 1, which is on the left, allows the user to choose between either a 3.3 volt or 5 volt supply. Switch 2, which is on the right, allows the user to either boost the 3.3 volt supply to 5 volts or take the 5 volt supply directly from the launchpad. The latter is the preferred option. However, this is not always possible, as TI's MSP430 G2 launchpad can only source a 3.3 volt supply. In order to prevent unnecessary power consumption, the boost converter should be off when sourcing 3.3 volts to the sensor modules. A new revision of the Grove Base Booster Pack soon to be released will incorporate only one switch instead of two. This will make it easier for the user by only having them choose between a 3.3 volt or 5 volt supply to source their modules. Next, let's open up Energia. Import the code example for this booster pack by going to File, Open, and navigating to your local directory for the Energia sketch. Also, be sure to include the local libraries Grove_serial LCD and Grove_humidity_temperature_sensor in your sketch by navigating to Hardware, MSP430, Libraries, under your Energia directory and placing them here. You will not be able to compile your sketch without these libraries. In the code example, we will include a few libraries to make our code compile. The header file serial lcd.h includes the function definitions for the LCD display, while software serial.h includes the definitions for displaying sensor data over a serial console. DHT.h needs to be included as a library for the temperature and humidity sensor to function properly. And finally, pitches.h is included because it encompasses a list of public constants available to the user and referenced in our program. Now, let's dig a little deeper into what the code is actually doing. You'll notice a few local functions defined at the top of our example. The main function that we want to focus on here is the sensor function, which is the main body of our code. The functions tempCalc and gasCalc both simply perform the calculations required for converting the analog data from a sensor measurement into a number with the appropriate units. Lastly, the blink function shown is the interrupt subroutine for the code example. Once the user presses push button 2 or simply push 2 on the launchpad, this subroutine will run and increment our loop counter, case count, used within the function loop. This loop counter is used to cycle through the sensors and modules that are attached to the booster pack. You'll notice that there are several local variables defined for the function loop mentioned above. These variables are simply the defined cases in a switch statement that the loop counter will increment over. There are also local variables defined for the analog and digital input pins, along with values for each sensor. As I had mentioned before, sensor function is the main body of our code for this example. However, before delving into this piece of code, we need to first look at the setup function where our program will begin executing. Within setup, we first set our connected LED module, defined as Grove LED, as an output pin. We also set push2 to be an output pin as well. In addition, we initialize both of these output pins with a value using the digital write function. Our LED module is initially set to a low voltage, which is off, and our push button is set to a high voltage when the button is not pressed. You'll notice too that there are several delay functions interspersed within setup and also throughout the code example. The reason for these delays is to account for any settling time on the hardware side. The last bit of code in setup is just simply initializing the LCD display, serial communication, and DHT sensor. The final line of code initializes the interrupt routine and tells us that when push2 is pressed, the interrupt subroutine, blink, will be called. Let's tackle the final piece of our code example by understanding sensor function. To start off, sensor function has three parts: choosing which module calculations or actions to perform, printing out module data to the LCD display, and finally, printing out data to the serial terminal. The printing of sensor data, whether it is to a console or the LCD, is mundane and explained thoroughly on Seed Studio's website. Let's instead talk about the logic behind our code once we know which sensor has been selected on our booster pack. Sensor function is described by a set of if statements. The first line of code makes sure that your sensor is not a buzzer. If it is not, it will perform an analog read on your current sensor independent of whether a module has a digital output, analog output, or serial output. The next if statement asks if your sensor is a temperature sensor, and if so, performs the required calculations. Subsequently, the next if takes these actions for our gas sensor. The final if statement asks whether your sensor is the DHT sensor for temperature and humidity. If that is the case, it uses library calls from dht.h to read the current temperature and humidity. Now, you might be wondering, what happens if the device is a buzzer? The code for this at the bottom of sensor function simply calculates a pre-orchestrated tune for the user and plays it through the buzzer using the function noTone. The code also blinks an LED while the tone is being played. And finally, we are done. Press the Verify and Download button on your Energia sketch to start scrolling through your sensors with only the touch of a button.